Have you ever wondered how complex software systems are designed? How do developers translate real-world problems into lines of code? Welcome to the intriguing world of object-oriented analysis and design, often abbreviated as OOAD. This is a methodology that forms the backbone of software development, enabling developers to comprehend and tackle complex problems. It's like a puzzle solver, helping us piece together the various aspects of a system. At the heart of OOAD is the concept of objects. These objects are modeled after real-world or abstract entities, and the relationships and interactions among them. Imagine building a city. Each building, road, and park would be an object, and the way they all interconnect and interact would form the design of your city. Similarly, OOAD allows us to construct a digital city, a software system, by focusing on objects and their relationships. So, OOAD is like a blueprint for building software systems. It helps developers understand and design complex systems. The first step in OOAD is Object-Oriented Analysis, or OOA. Picture this as the foundation stage of building a house, where you're assessing the terrain, sketching the blueprint, and deciding where to place the rooms. In the realm of software development, OOA is about understanding the problem you're trying to solve, the problem domain. It involves looking at the world from an object-oriented perspective, identifying the key objects, their attributes, and how they interact with each other. Let's unpack some of the core concepts. First, we have use cases. These are like little stories that describe how a user or an actor interacts with a system. They're useful in defining the system's functionality and outlining the user's goals. For instance, a use case for an online shopping app might be user adds item to shopping cart. Next, we have domain modeling. This is where we create a model that represents the main entities and their relationships in the problem domain. It's like making a map of the terrain before starting construction. In our online shopping app example, the main entities could be user, product, and shopping cart, and we would define how they relate to each other. Lastly, there are user stories. These are brief, simple descriptions of a feature told from the perspective of the end user. They help to provide a user-centric view of the requirements. A user story for our shopping app could be, as a user, I want to be able to add products to my shopping cart. So why do we do all this? Well, OOA is essentially the detective work in software development. It's about investigating the problem, gathering clues, and piecing together a clear picture. It helps us figure out not only what we need to build, but also how it should function from the user's perspective. It's about asking the right questions to ensure we're building the right thing. And that's the essence of object-oriented analysis. It's a crucial first step that lays the groundwork for everything that follows in the OOAD process. OOA is like the detective work in software development. It helps us figure out what we need to build. Scene script. Once we understand what we need to build, the next step is to figure out how to build it. That's where object-oriented design, or OOD, comes in. OOD is like the architect's blueprint in the world of software development. It's where we translate the requirements identified during object-oriented analysis into a system architecture, giving form and structure to our solution. Let's dive into the key concepts of object-oriented design. First up, we have class diagrams. These are the heart of OOD. They define the classes, their attributes, and their methods, essentially mapping out the DNA of our objects. Class diagrams also depict relationships between classes, such as inheritance and associations, providing a bird's-eye view of the system's structure. Next, we have sequence diagrams. These are the storytellers of our system. They illustrate the interactions between objects over time, showing the sequence of processes and how data flows within the system. They're like a play-by-play of the system's inner workings. Then we have state diagrams. These are the biographers of our objects. They depict the different states an object can be in, and the transitions between states. It's like tracking the life cycle of an object, showing its behavior in response to events and conditions. Lastly, we have collaboration diagrams. These diagrams are all about teamwork. They focus on how objects interact and collaborate to achieve specific goals or outcomes. They emphasize the structure of communication within the system, showing who talks to whom and how they pass information. Each of these diagrams offers a different perspective on the system, shedding light on various aspects of its design. Together, they provide a comprehensive view of how the system will function and interact, serving as a roadmap for developers during the implementation phase. OOAD is where we start getting our hands dirty, so to speak. It's where we start turning our understanding of the problem into a solution. And that, my friends, is the beauty of object-oriented design. It's the bridge between what we need to do and how we're going to do it. It's where ideas become reality and problems become solutions. The language we use to describe our analysis and design is called the Unified Modeling Language, or UML. This tongue of technologists is a standardized language that visually represents object-oriented analysis and design concepts. It's the sketchpad where we draft the blueprints of our software solutions, and it's key in facilitating communication and understanding of system design. UML is like the artist's palette of software development, offering a variety of diagrams to paint a vivid picture of the system's structure and behavior. These diagrams are the canvas where we illustrate the flow of processes, the interactions between objects, and even the states an object can exist in. Let's delve a bit into some of the most commonly used UML diagrams. We'll start with the class diagram, the most widely used diagram in UML. It's like a family tree for our system, showing the classes, their attributes, methods, and relationships. It's here that we depict inheritance and associations, giving us a clear view of our system's structure. Next up are sequence diagrams. These are like comic strips for our software, illustrating the interactions between objects over time and showing how processes flow within the system. They're invaluable for understanding the sequence of events in our system and how objects communicate. Then there are state diagrams, the biographies of our objects. They depict the different states an object can be in and the transitions between states, showing the object's behavior in response to events. These diagrams are particularly useful when dealing with complex objects with numerous states. Last but not least, we have collaboration diagrams. These diagrams focus on the interaction among objects to achieve specific goals or outcomes, emphasizing the structure of communication. They're like the script for a well-coordinated play, where each object knows its role and how to interact with others. In essence, UML is the lingua franca of object-oriented analysis and design. It's the language that allows developers to communicate their designs clearly and effectively. It's the tool that helps us turn abstract concepts into concrete solutions, bridging the gap between idea and implementation. So, the next time you're tasked with designing a system, remember, speak in UML and let your designs do the talking. UML is the lingua franca of OOAD. It allows developers to communicate their designs clearly and effectively. So why do we go through all this trouble? What are the benefits of using OOAD, you may ask? Well, there are several compelling reasons why OOAD has become a cornerstone in software development. Firstly, let's talk about modularity. By focusing on objects and their interactions, OOAD promotes a modular design. This means that the system is divided into separate, independent units, each responsible for a specific functionality. Imagine it like building blocks. Each block is a standalone piece that, when put together, form a complete structure. This modularity allows developers to isolate components, making it easier to develop and maintain the system. If an issue arises, it can be traced back to a specific module, reducing the impact on the overall system. Next up, we have reusability. Object-oriented design encourages the reuse of code through concepts like inheritance, encapsulation, and abstraction. Inheritance allows new objects to take on the properties of existing ones, while encapsulation hides the complexities of these objects, and abstraction focuses only on the essential features. This combination reduces duplication, promotes consistency, and saves valuable development time. It's like having a set of tools that you can use again and again, each time saving you the effort of creating a new tool from scratch. But the benefits don't stop there. These principles also contribute to increased reliability and flexibility. The isolation of components means that a change or error in one part of the system is less likely to affect others. Moreover, the use of abstraction and encapsulation allows for easier modification and extension of the system as requirements evolve. So to wrap it up, OOAD helps to manage the inherent complexity of software systems. It provides a structured approach to design, making it easier to understand the system as a whole. And by promoting modularity and reusability, it makes the development and maintenance of the system more manageable. In short, OOAD makes complex software systems manageable. It provides a structured approach that helps developers build systems that are scalable and maintainable. So next time you're faced with a complex software challenge, remember the power of OOAD. In this video, we've taken a whirlwind tour of object-oriented analysis and design. As we've seen, OOAD is a powerful methodology that allows us to model complex systems in a structured and intuitive manner. We've delved into the intricacies of object-oriented analysis, where we explore the problem domain and identify the key objects and their interactions. We then transitioned to object-oriented design, where we translate our analysis into a system architecture, defining the classes, objects, and their relationships. We also touched on the unified modeling language, a standardized language that helps us visually represent our object-oriented concepts, facilitating communication and understanding of system design. And let's not forget the many benefits OOAD offers, including modularity and reusability, which not only streamline the development process, but also enhance the maintainability of our software. So the next time you use a software application, spare a thought for the developers who used OOAD to turn a complex problem into a solution that makes your life easier.